One of my students pointed this out, and I know some of you all don't have a textbook. You know, need to know the difference between type 1 and type 2 muscle fibers before I begin running my mouth. You notice type 1 muscle fibers are slow twitch in which they're going to have a large number of mitochondria, and these are going to be your postural muscles because they contract for a long period of time, whereas type 2 muscle fibers are fast twitch. You're going to notice they're going to have fewer mitochondria. They're going to, Mr. Gilman, they're going to fatigue very easily. That's why you like rub your eyes, because those muscles get tired real quick. So if you want to take a picture of this, feel free to come up and take your picture. However you want to. If I was you, I would use flash so that way I'll come closer. Instead of using that zoom, I will come closer instead of trying to get it way back there. That way you can see the words later when you're trying to zoom in on your cell phone. It's hard to get them to believe me. I gotta know what I'm talking about. I shoot real cameras, so I gotta know what I'm talking about. All right, so we noticed that we're on slide 30 of chapter 9, right?
I'm just kidding.
No, it's slide 102.
102.
Slide who?
102.
Oh, we at the end.
Yeah. That was the first time we stopped.
We on slide 102?
Yeah.
Oh man, y'all gonna be over with this in no time. Yeah, y'all way ahead of my other class.
You can still sort of.
So here's the catch. We got to set the time to see what there was really. Here's the cool thing. There's really 5 lobes. There's a frontal lobe. There's a parietal lobe. There's a temporal lobe. There's an occipital lobe. And then the 5th lobe is the insula. The insula, Mr. Gilmore, is that main area that they're talking about right here. When they start talking about the basal nuclei, that's the inside. That's that 5th lobe, really. Mr. Gilmore, but I need you to tell me about that a little bit more. Well, here's what I got to tell you. There's 2 conditions. One I know real well, the other one I don't know a lot about it because I haven't researched a lot about it. But one I know real well. And the presentation looks like this. The symptomatology, the person's body gestures does exactly what I'm saying. And one of the most famous people of all time is said to have had this. One actually went back into acting after he got treatment, but the other one just passed away. And it's amazing how people regarded him as the greatest ever when he passed away. But throughout a lot of his life, they ridiculed him. Anyway, so Mr. Gilmore, watch this here. This person has a stooped appearance. That's number 1. Stooped posture. They have what we call a shuffling gait, meaning that the way that they walk, Mr. Gilmore, is constantly staggered. So that's a shuffling gait. They have what we call pill rolling fingertips. So when they're walking, they're doing this. Now, Mr. Gilmore, they have restless tumors, meaning that their body is always shaking no matter what. That's called wrestling tumors. Then they have this drool out of the side of their mouth. Mr. Gilmore, those 5 characteristics help me understand what Parkinson's disease looks like. But Mr. Gilmore, what's wrong with Parkinson's? Here's what happens. The main thing that happens, Mr. Gilmore, there's a major decrease in dopamine. If you notice, it tells us the basal nuclei are a mass of gray matter located deep within the cerebral hemispheres that relay motor impulses from the cerebrum and help to control motor activities by producing the inhibitory neurotransmitter dopamine. The basal nuclei included the caudate nucleus, the putamen, and the gluteus pallidus. The neurons of the basal nuclei interact with the motor cortex, the thalamus, and the cerebrum. Altered activity of these nuclear neurons produces signs of Parkinson's and Huntington's disease. The main one I'm talking about today is Parkinson's disease. Because I really put some time and effort into studying and understanding it. Huntington, I didn't put a whole lot of time in it. I ain't going to even sit here and try to fake it. I'm telling you, honest to God truth. But Mr. Gilmore, here's the catch. How do they treat Parkinson's? They give you what they call L-DOPA. L-DOPA is the precursor form to dopamine. What does that mean, Mr. Gilmore? See, L-DOPA is smaller so it can pass through the blood-brain barrier. See, there's this cute little thing that we call the cerebral aqueduct, or the aqueduct of Sylvius, that connected the third to the fourth ventricle. So, Mr. Gilmore, I needed something very small in order to get through to the brain so that the body can convert L-dopa into dopamine, so that I can help with this condition. Now, they were able to do a whole lot of good with Michael J. Fox. Then next thing you know, he went back into acting. Y'all remember that? Everybody with it?
Mm-hmm.
But they think there was a combination of problems that exist with Muhammad Ali. From all the what? Trauma to the head. If that much is true, Mr. Gilmore, we're able to look at the fact that we got two ventricles. We got a left lateral and a right lateral ventricle. After which we were able to find out there's a third and fourth ventricle. But here's the deal, Mr. Gilmore. There's something that has to connect the left and right ventricle. The left ventricle would be number one, the right ventricle would be number two. What connects them? Well, you call it a corpus callosum. You found out that the interventricular foramen connects the lateral ventricles to the third, and the cerebral aqueduct connects it to the third and the fourth ventricles. We gotta remember that cerebral aqueduct. The ventricles are continuous with the central canal, the spinal cord, and the subarachnoid space filled with cerebral spinal fluid. Here's the schematic that shows me left and right lateral ventricle. What connects them, Mr. Gilmore? The cute thing called the interventricular foramen, but Mr. Gilmore, that's really right above who? The corpus callosum. If that much is true, what's going to connect the third and fourth ventricle? Well, Mr. Gilmore, that's called the cerebral aqueduct, or the aqueduct of Sylvius. And anytime someone starts talking about the blood-brain barrier, they're talking about that structure. Because they're trying to tell you, how can I get medicines to the brain? See, the main thing is, Mr. Gilmore, we have the medicine that could combat a lot of brain diseases or disorders. But they're so large. So how are you going to get them to it? Mr. Gilmore, most times they got to what? Draw a hole in the skull to administer the medicine. Because again, it has to get past that blood-brain barrier. And that passageway is so small. The fourth ventricle, the third ventricle, what connects them? See how small it is? That's called the cerebral aqueduct of Sylvius. Everybody with it? And they don't look that small to me, you gotta think about it. It's a blown up image. We're talking about it inside of someone's head in comparison. The next thing I'm going to talk about is the choral plexus. Mr. Gilmore, you showed me what the choral plexus was, but you told me I didn't have to learn it. Here's the catch. That's a specialized capillary that has a lot to do with the cerebrospinal fluid. You find out the choral plexus is specialized capillaries from the pia mater secrete cerebrospinal fluid into the ventricles. Most cerebrospinal fluid arises in the lateral ventricles. Cerebrospinal fluid has nutritive as well as protective cushioning functions. Cerebrospinal fluid circulates through the ventricles and connecting passageways into the subarachnoid space where it's reabsorbed back into the blood. And so here's a schematic that shows you. Right below the fornix, I see this cute little structure that you're talking about, and that's my what? Choroid plexus. Plays a vital role when you start talking about cerebrospinal fluid. Everybody with it? Man, it's cold in here. Mm-hmm. If all that's true, I gotta keep moving because it's cold. The diencephalon lies between the cerebral hemispheres and above the midbrain. The main parts are the thalamus. Mr. Gilmore, we remember the thalamus. The thalamus was that what? Relay switch. When I needed to call my little loved one in California, I had to call operator, connect me to Mr. Gilmore. That's what the thalamus does. He's the connector. He's the relay switch. And then we found out the hypothalamus. What was his main job? Y'all ran on other things. What was the hypothalamus' main job? Who?
The hormones?
Hormones. So he said my main job was hormone production. You're gonna find him do some more things, but that's what his main job was, hormone production. Other portions of the diencephalon are optic tracts, optic chiasm, infundibulum, the posterior, pituitary, mammillary bodies, and the pineal gland, all of which you have seen in the lab. Now, if that much is true, Mr. Gilmore, we're able to see the thalamus functions in sorting and directing sensory information arriving from other parts of the nervous system, performing the services of both messenger and editor. pinpoints the origin of the sensory input, produces general awareness of sensations. Descending fibers from the cerebral cortex also communicate with the thalamus. If that much is true, the hypothalamus maintains homeostasis by regulating a wide variety of visceral. Anytime I see the term visceral, what does it mean? Organ. Anytime I see that term visceral, I know they're talking about organ. Activities by linking the endocrine with the nervous system, Mr. Gilmore, here's the catch. Those are the two most powerful systems in the body, because we found out the nervous system controls and coordinates everything in the body, and the endocrine system says, I'm going to tell everything what to do by hormones. If that much is true, you'll find out the hypothalamus is going to regulate heart rate and arterial blood pressure, regulate blood temperature, water, electrolyte balance, hunger, and body weight, control movements and secretion of the digestive tract, helps to regulate sleep and wakefulness, which really is the main job of the pineal gland or pineal body, but we'll get to that. Stimulates the posterior pituitary to secrete stored hormones, Mr. Gilmore. Here's the catch. Posterior pituitary only houses two hormones. What's the two hormones that's found in the posterior pituitary? I'm glad you asked. Oxytocin and antidiuretic hormone. Do it again. Oxytocin and antidiuretic hormone. Those are the only two found in the posterior pituitary. It's ridiculous how cold it was. Yesterday and then they must have get the memo. Whenever you see the limbic system, hey, y'all got to know what the limbic system do. Because y'all got a group from Houston called H-Town. And H-Town used to sing about what? Emotion. Limbic system is all about emotions. Fear, rage, happiness, sadness. This is an area of the diacephalon that controls your emotional experience and expression by generating pleasure or pleasant or unpleasant feelings about experiences. The limbic system guides behavior that may enhance the chance of survival. The next thing we get to talk about is the brain stem. We talked about that. We talked about in lab how you group certain things together. That makes up the brain stem. How you group certain things together, and that makes up the hindbrain. The brain stem consists of the midbrain, the pons, and medulla oblongata, lies at the base of the cerebrum and connects the brain to the spinal cord. If that much is true, we get the chance to look at the midbrain. It's located between the dicephalon and the pons. Contains bundles of myelinated nerve fibers that convey impulses to and from higher parts of the brain. It also contains massive brain matter that serves as centers for auditory and visual reflexes. Midbrain is exactly what it says. It's in the middle. Then we got the pons. Pons is the bridge. He lines between the midbrain and the medulla oblongata. He transmits impulses from the brain and the spinal cord and contains centers that help regulate the rate and depth of breathing. The ventral surface has transverse fibers that communicate with the cerebellum. Now, if all that's true, we get to look at the medulla oblongata. Before I even talk about that, I need you to write for the medulla oblongata, I want you to write for the decusation. What does that mean? That means crossing over. Decusation means to get more means crossing over. So when I say decusation, that means the right side of the brain can control the left side of the body and vice versa. That's why we were able to talk about my mom's situation when she had those strokes. When her entire left side of her body was paralyzed, that's because the right side of the brain had those strokes. Everybody with me? Yeah. The medulla oblongata transmits all the ascending and descending impulses between the brain and spinal cord. Most of these tracts will cross the pyramids of the medulla oblongata. The medulla oblongata also houses nuclei that control visceral functions. Again, that means organs, including cardiac center, which relates to the heart, which is heart rate, vasomotor center for the blood pressure control, and respiratory center that, along with the pons, have control the rate and depth of breathing. Other nuclei in the medulla oblongata are associated with coughing, sneezing, swallowing, and vomiting. Throughout the brainstem, hypothalamus, cerebrum, cerebellum, and the basal ganglion, a complex of network of nerve fibers connecting tiny islands of gray matter. This network is the reticular formation. Decreased activity in the reticular formation results in sleep. Increased activity results in wakefulness. The reticular formation filters incoming sensory impulses. When I look at the cerebrum, the first thing I want to think about, Mr. Gilmore, is the fact that the cerebrum is all about coordination. How you coordinate. Not your clothes, but Mr. Gilmore, just the basic premise of walking. When other people pull you over, go whoop whoop, walk this line. And trying to see if your coordination is intact. Now, Mr. Gilmore, you had a friend that was in chiropractic school with you, and he got off by saying what? I have cerebellar problem. He actually had one of his boys to produce him a doctor's note that he has to keep with him at all times. Meaning that just to give him, I can't walk in a straight line. I'm gonna walk in what? A circular pattern. Kind of puts you in the mindset of a weekend at Bernie's, that old movie. Everybody remember that? No, I really don't care. But Mr. Gilmore, the cerebellum is located beneath the posterior part of the cerebrum and on top of the brainstem. The cerebellum is made up of two hemispheres connected by the vermis. A thin layer of gray matter is called the cerebellar cortex, lies outside a core of white matter called the arbor vitae. The arbor vitae means tree of life. We saw that in lab. So here's a schematic that shows you exactly that. The cerebellum communicates with other parts of the central nervous system through the cerebral peduncles. The cerebellum functions to integrate sensory information about the position of the body, coordinates skeletal muscle activity, and maintains posture. We'll never get to look at the peripheral nervous system, Mr. Gilmore. We spent all that time talking about the central nervous system because that was brain and spinal cord. But now we get to talk about peripheral nervous system, Mr. Gilmore, that's everything else. Cranial nerves is everything else. Peripheral nerves, everything else. Spinal nerves, everything else. Accessory nerves. Mr. Gilmore, if it's not a part of the brain and spinal cord, but it's still nervous, it falls under the peripheral nervous system. That is correct. If that much is true, in a minute I'm gonna have my man come out and hang out with me because we'll have to go over some things called cranial nerves. You'll notice, Mr. Gilmore, they show us brain and spinal cord falls under the central nervous system. Everything else is peripheral nervous system, whether it's cranial nerves or spinal nerves. For Mr. Gilmore, here's the first thing I gotta do. I gotta go over the cranial nerves, and I need you to help me understand this. So we're gonna do this thing called cranial nerve testing. My man, come on for me. Sit in that chair. What you been doing here, Mr. Gilmore? I got to do this thing called cranial nerve testing because there's 20 questions. There's 20 questions on the exam
Which one?
that comes, the second lecture exam. There's 20 questions on the lecture exam, so I know you got a fifth of the test that's been answered just by me doing this here with him. So that means you need to know this. Why do you put so much emphasis on cranial nerve testing? Because here's the catch. You can figure out or diagnose a lot of things that happen with a patient just that you know these things. So Mr. Gilmore, what are you about to do? I'm going to go over again. Cranial nerve testing. Well, do you want me to record it? If you want to. It might be beneficial to you. So Mr. Gilmore, this might be something that can help me understand a lot of the things that we're going to see in our health-related fields.